Welcome to digital signal processing. In this video, I am going to talk about what is a signal. Myself, Dr. T. Veeramanandaswamy from Veera Electronics. A signal is a source of information. Generally, a signal is a physical quantity that varies with respect to time, distance, position, temperature, pressure, like any independent variable. So a signal can be anything which conveys information. Mathematically, a signal can be defined as a function of one or more independent variables such as time, distance, position, temperature, pressure, etc. For example, a speech signal. The source of speech signal is our vocal pressure. So based on our vocal pressure, the amplitude will be changed. So that amplitude varies, our vocal pressure varies with respect to time. So it is actually one dimensional signal. Why? Because the signal amplitude depends on the only one independent variable. Okay, so if that signal depends on only one independent variable, that such signal is called one dimensional signal. So we'll see, this is the speech signal amplitude with respect to time. So time in seconds, or y-axis variable is amplitude ratio. So amplitude ratio is measured in dB, decibel. So sound is measured in decibel. The x-axis variable is time, then y-axis variable is sound in dB, that is amplitude of that sound. So we are getting some variations in that amplitude with respect to time based on our vocal pressure. Okay, so it is an example for one dimensional signal. Okay, so speech signal f of t means function of time variable, is created by changes in air pressure or vocal pressure, and it is represented by a function of time. So the next example is a black and white picture. The light intensity of the pixel is changed with respect to the spatial coordinate. Okay, black and white picture is the signal. So that signal gives many information. So let me see an image. So there are two independent variables, so that are all fixed. So in that pixel, okay, so each pixel having width and height, so that is same throughout the picture, right? So in all the pixels in that picture, so here only the changes in the brightness of the pixel. So the brightness of the pixel or light intensity of the pixel can be represented as the gray value. So the gray value can be used to represent the light intensity. Suppose we are using 8-bit integer to represent gray level. So the value of intensity, gray level value of intensity from 0 to 255. So 0 means it represents black color, 255 represents white color. Okay, so this area, that value will be close to 255, right? So in that area the value will be close to 0. Why? Because this is a black color pixel, so the gray level value of that pixel is almost 0. So here this pixel gives you the white color, so that gray level value will be near to 255. So that we look at a particular pixel intensity, how to represent each and every pixel. So we have to use this f of x comma y in that case. Okay, so the function of that particular pixel. Okay, so the pixel at coordinates 9 comma 2. Okay, so 9 is the column number, that is ninth column. Then 2 is the row number, this line is the row 2, and this line is the column 9. So exactly this pixel. Okay, so light intensity of the pixel is 110. So this 110 is the 8-bit integer representation. So 110 is the gray level value of that particular pixel. In an image, each and every pixel can be valued with the help of the function f of x comma y. That there are two independent variables, so that it is the 2D signal. Then video signal. So sequence of frames means sequence of images. So these sequence of images are to be played in proper time, we are getting the video signal. Okay, frame or image having two spatial coordinates, and the sequence of frames are to be played with respect to time also, so that the third variable also added with the two spatial coordinates x comma y, so that video signal having three independent variables x comma y, that is width and height of the pixel, and t is the time variable. So we are going to play 200 frames per second, you are getting video, right? That is f of x comma y comma t is the function of video signal. So let me see how the video is created. So the frames are sequentially organized, and the frames are played in the sequential manner, we will get the video signal. So signal is the representation of information, right? So this is the examples of signals. So this is the signal from mic. The amplitude or vocal pressure is changing with respect to time. So here only one independent variable, so that this is the 1D signal. ECG signals are generally obtained from standard 12 leads cardiograph. For electrocardiogram measurement, 12 leads are connected to the human chest, arms and legs. So these electrodes are used to record the ECG wave on electrocardiograph. ECG wave having four entities: so P waves, a QRS complex, a T wave, and a U wave. Okay, so the P wave represents atrial depolarization, then the QRS complex represents ventricular depolarization, then T wave represents ventricular repolarization, then U wave represents papillary muscles repolarization. This PQRS T and U wave can be obtained from the various electrodes. ECG signal can be collected from any source, right? So it is the multi-channel signal. So all the signals are combined together in the electrocardiograph, and finally we are getting this pattern. So this pattern, PQ or STU pattern, varies with respect to time only. Y-axis is bioelectric potential of that signal, it is an amplitude. Then x-axis is time variable, so that it is 1D signal. Then we already seen black and white pictures or having number of pixels. So width and height of the pixels or the independent variable, that is x comma y, so that the black and white image having two independent variables, so that it is 2D signal. Then video signal having a sequence of frames or sequence of images. We are going to play the images with respect to time, f of x comma y comma t. So it has three independent variables, so that video signals are 3D signal, that is three-dimensional signal. The signal can be classified based on the nature of independent variables such as time. So they are continuous time signal, that is CT signal, and discrete time signal or DT signal. So continuous time signal having continuous amplitude with respect to continuous time, discrete time signal having continuous amplitude with respect to discrete time. The signal can be classified based on the nature of the dependent variable, that are analog signal and digital signal. So analog signal having continuous amplitude with respect to continuous time, similar to the continuous time signal or CT signal. Then digital signal having discrete amplitude with respect to discrete time. So we'll look at continuous time signal. So there exists a unique and real value function for every instance of the independent variable time. So a finite real valued smooth function x of t of an independent variable time. So time is the x-axis variable. So that time value ranges from minus infinity to plus infinity. So the signal can have continuous amplitude with respect to continuous time, so therefore it is known as continuous time signal or CT signal. We can see here this picture represents continuous time signal. So x-axis is the time variable, then y-axis is the voltage. It is actually the voltage signal, maybe from analog electronic circuit. So that circuit producing a wave like that, it is an voltage signal. So this signal keep on changing with respect to continuous time, so that the signal having continuous amplitude with respect to continuous time, so that it is called continuous time signal. Then continuous time signal is represented by x of t. So x means the function x of t, f of t, y of t, like that. Okay, continuous time signal is also called analog signals. In general, all real world signals are normally analog signals that will be bounded in amplitude. So they will be bounded in power and energy also, because no infinite source of energy is available. Okay, then we look at discrete time signals. Discrete time signals obtained from the continuous time signal or analog signal. An analog signal is sampled at equally spaced intervals along the x-axis, yields discrete time signals. So the sampling is done on the x-axis variable. Discrete time signal is the continuous valued function of a discrete instance. So the discrete time signal can be represented by x of n or x of nt. So n takes it of integer. The time interval between the integer is t. So that x of n define only for integer value of n. So for example, if x of t denotes temperature as a function of time, so this is the temperature reading with respect to time. So this is the continuous temperature values with respect to time variable. So if you want to look at the temperature values for every 1 second, then we need to sample this signal at 1 second. So in that output of the sampler, we are getting only the signal like this. Okay, only the stems are in that signal. So the stems are at the particular instance, that is actually n is here instance. Okay, so n is here instance. N takes a set of integer. The time interval between the integer is t, so that is a sampling period. X of nt or x of n define only for the integer value of n. So in general, discrete time signals are only defined in equally spaced intervals. So here discrete in independent variable, continuous in dependent variable. Then we look at digital signal. So after sampling, the signal is quantized. That means the amplitude can take only a finite number of values. The finite number of values or quantization levels or binary steps depends on the resolution of the digital signal. So you can see here, this is the continuous time signal. That continuous time signal is sampled here. So this sample value is adjusted to the quantization levels. Okay, the signal amplitude can be represented as the finite number of values or quantization levels. So for 3-bit digital value, we can have 8 quantization levels or 8 finite number of values. Okay, so it starts from 000, 001, 010, 011, 100, 101, 110, and 111. Your function value for any instant should be any one of this value. Amplitude of that first sample is maybe here. Okay, so for the digital representation, the actual amplitude will be adjusted to 001, right? So this is the quantization. So by using truncation and round off, so that actual value will be adjusted to the nearest quantization level, right? So your value will be 001. Then if you consider this the second sample, so the amplitude, that sample is here, this amplitude is nearest to this quantization level, so that 0 1 1, this amplitude will be adjusted to 0 1 1, so that in that instant the digital value for that sample will be 0 1 1. Okay, so this is the concept we are using to convert a discrete time signal into digital signal. Therefore, the signal that are discrete in both amplitude as well as time is called digital signal. So here you can see how we will convert discrete time signal into digital signal. This is a discrete time signal. So after quantization, we will get the digital signal. So in that the amplitude also discrete with respect to discrete time. So finally, all signals are analog form in nature. So generally we are getting analog signal from the physical quantity, so that the signal source is the physical quantity. Then we are using sensors and some other circuits or equipment to convert that physical quantity into an electrical quantity. So finally we are getting analog signal. So analog signal having continuous amplitude with respect to continuous time, it can be denoted as x of t. X of t means function of time. Then we will get the discrete time signal from the analog signal by sampling. Time variable is sampled with the uniform sampling period. So here n is the integer, 1t, 2t, 3t, 4t, 5t and 6t and so on. So this x-axis will be discrete. After sampling, then x-axis will be discrete. So look at that amplitude of that signal. Amplitude is having still that continuous nature. A discrete time signal is a continuous valued function of a discrete instance. Then we will get the digital signal from the discrete time signal by quantization. So the quantization process will introduce a finite number of values in amplitude axis. Resolution of the digital value will fix the number of finite values in y-axis. Digital signals are discrete with respect to discrete time. X of n is a sequence of discrete values at any given time with a finite time increment. Thank you.